Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Aina Fakihah binti Muhammad Akmal and I am from IAC 5B. So for this video, I'm going to explain my third assignment. We have 5 tasks to be done. Okay, for the first task, we have to create a simple LABVIEW VI. The purpose of this task is to learn how to generate a simulated sine wave in LABVIEW and compare it with a user-defined value. This will be the limit value that will be entered by the user, and it will activate an alarm indicator as an output when the signal exceeds that limit. Through this exercise, I learned how to use essential LABVIEW components such as the simulate signal block, comparison function, numeric controls, numeric indicator, and the while loop structure. This task help build fundamental skill in signal processing, threshold monitoring, and basic data flow programming inside the LABVIEW environment. Next, I will be explaining the step-by-step demonstration.
The first step is to place a while loop. On the plot diagram, right-click to open the function palette, expand programming, then choose structures, and pick while loop. Draw the while loop in the diagram area. These while loops are important as it allows continuous generation of simulated data until a stop condition. And then we go to the quick drop and choose simulate signal. Double-click it and check Simulate Acquisition Timing in its configuration. This express VI generates the test waveform and simulates sample data. Add waveform graph indicator. Right-click at the simulate signal and choose Create and choose all controls and indicators. Remove all the unwanted things and only left the waveform graph indicator. Add stop button. A stop button can control the while loop condition. Add limit control. Vertical pointer slide. Go to the front panel, open control palette, and go to the numeric. Set its property. Label as limit. The user will set the slide to change the threshold for the alarm. And then we need to add alarm LED. We choose round LED. Place it on front panel and rename it Alarm via Properties. Next, at comparison express VI. Compare condition must be greater. This block outputs true when operand 1 greater than operand 2. Then we need to wire up comparison inputs or outputs. Wire the simulate signal output, the data stream, to operand 1 of the comparison. And then wire the limit control to operand 2. Then connect the comparison result output to the alarm LED. If the result output expect Boolean, ensure the alarm is Boolean. And then run the VI and test.
I will explain how the system works. First, the simulate signal block. The simulate signal block will generate a sine waveform. The waveform is displayed on the waveform graph while also being sent to the greater block. The limit value is compared with the signal amplitude. If the signal value exceeds the limit, alarm equal to true. If the signal is below the limit, alarm is equal to false. Okay, the loop will repeat this process continuously until the stop button is pressed, as we have all these components in the while loop. Then I will tell you the example or the real world application. This type of system is commonly used in phase sensor monitoring system, 2 industrial automation, and 3 safety and warning system. Okay, for example, the sensor monitoring system. The temperature sensor will trigger an alarm when overheating occurs. Pressure sensor will detect dangerous pressure levels. Light sensor will detect sudden brightness or darkness. Next, industrial automation. Industrial automation machines stopping when vibration or noise reach unsafe levels. Finally, during this task, I learned how to generate a signal, visualize, set a threshold value, and use comparison logic to activate an alarm in LABVIEW. I also become more familiar with how the front panel and block diagram works together and how data flow through each function inside the while loop. I still face a lot of change. One of the challenges that I face is I do not fully remember where certain component and certain icon or function are located within the palette. This will make me more slower when building the system. However, I will overcome this by exploring more on the palette one by one, using the quick drop function when necessary. Overall, this exercise improved my understanding of LABVIEW signals, processing capabilities, and helped build confidence in designing simple real-time monitoring system. That's all from the first task.